Good morning everyone. Good morning everyone. Before going to start the class, let me say something about Unacademy. Before going to start, let me say something about Unacademy, so that we can go to the actual topic. Right? These will be really useful to you, so that is the reason I am saying. Right? It's 2024 purpose. Those people who are preparing for GATE 2024. Right? For them, one batch we started, Udan batch, which is going to be start January 28th onwards. Right? Use the code Reddy sir, join in that batch. Udan batch is starting, right, for 2024 people. Use the referral code Reddy sir. It is me. I am teaching in Unacademy algorithms, data structures, programming, compiler design, theory of computation, computer network, discrete mathematics, and digital. These are the subjects which I am teaching. Right? If you follow all these subjects from me, you will get the full marks. My suggestion is please follow without delaying. Next one. There is one more batch starting, Bunyad batch. It will start from January 28. You can join in that batch also. If you join the Udan batch, the advantage is what you are going to get is India's top educators will teach. Access to live as well as recorded also. Access to all GATE digital books. Live test and quizzes followed by analysis classes. Analysis to PYQs and video solutions from 2011 onwards. 5,600 plus unique practice questions are there. Test series with live ranking to know where you stand among peers. Daily practice problems, structured courses, interactive live classes, right? Daily doubts clearing sessions. So many advantages you will get. So many. My suggestion is, if you are serious about 2024 GATE exam or 25, please without delaying join. This is my suggestion to you. Without delaying join. And one more, 30% offer also going on. Right? You can join plus or iconic. My suggestion is go for iconic. My suggestion is please go for iconic. Get up to 30% off. Go for iconic, plus or iconic, you can go. Iconic is my suggestion. Use referral code Reddy sir. Use referral code Reddy sir. Right? Fine. Next one. So, right? Yeah, same thing. 30% offer is going on because of Republic Day. So please utilize this. Price is going to be increased 10% very soon. Next one. Right? This one also, Raudra lectures also available. So you can join this also. Now this is me. So I'm starting. Right? I already started January 18th. I already started programming data structure. 1 or 2 small topics are over. You can go for recording also. 1 or 2 small topics are over. You can go for recording also. 6 a.m. morning programming data structure started. Hashing is completed. You can see the recording. Right? Now I started the graph traversal. Right? So my suggestion is please join in this batch. It will be really useful to you. Use referral code Reddy sir. And one more thing is, first I am starting the data structures now, followed by algorithm will be there. And the evening, if you see, that's the morning. Evening, if you see computer network I am teaching, followed by TOC will be there, followed by compiler design will be there, discrete mathematics. So totally 8 subjects are there. Morning to evening to. So like that. So I will keep on continue, almost like 8 subjects. Remaining subjects purpose, so many good teachers are available. So my request is, if you are serious 2024 or 2025 GATE exam, it is a correct time to start your preparation. Right. So one more batch I am starting, foundation batch for 2025 people. Next one, all India level there is a mock test is going on. Please enroll for this. Please enroll, and to the 29 of this month there is a mock test. It is a really great opportunity to test, right, how much practice you have. It is a really great opportunity. Right. So let's go to our today's class. Right. Expected question session. Right. This is the problem. Can you try what is the answer of this problem? I will give answer. Please try. Right. What is the answer of this problem? let me know what is the answer of this. This is a really nice problem, so you can go through it one time. So the internet host is roughly doubling in size every 18 months. Approximate estimates puts the number of hosts in it at 7 million in January 1996. Use this data to compute the expected number of internet hosts in the year 2008 in billions. Means you want to say that, right? The number of hosts he is having, right, at 1996 is going to be 7 million, and every 18 months is doubling it. Every 18 months means every 1.5 year is doubling it. In 2008, what are the expected number of users in billions? Right? I think it is something like an aptitude question, right? So to make it simple, let me do like this. To make it simple, let me do like this one. So I'm writing here, lack of space, I'm writing 1996, 7 million. So for every 1.5 year, so I think it's going to be 97.5. It's going to be 14 millions. Right? Add 1.5 once again. 97, so 98, 99, 99 years. Right? Right? 1999. So 28 million. Just double every time. Because of 2008, I think it's very soon it will come. Right? Next one. So it is going to be 2001, 2000 and half, right? 2000 and half. Will goes to 28, 56 million. Now it's going to be, right, 20, right? Next one is going to be 21, 22. Is going to be 56 means 12, right? 112 million. Check if I have done anything wrong. 96, 97 and half, right? 98, 99. So 2000 and half, 2001 and 2002, right? Fine, perfect. Next one is 3 and half. Is going to be 224. Right? Next one is, I think, 5. 448. Next one, 6 and half. So 48 means 96. 896 million. Right. Next one, 7, I think 8. So 896, 896. Right? 96, 96 means I think 200, 8 less. Right? 8, 8, 16. 16, 17. 17, 92. Am I right? Please verify. 16. So 17, 1792. 96 means 4 less. So 1792 million. If you want billion, divide by 1000, which will goes to 1.792 billion. So that is the answer for this. Just to make every year make, right? Every 1.5 year double it. Every 1.5 year double it. Every 1.5 year double it. So like that. Now, can you help me? What is the one more question is given? In order to connect these many hosts, means in order to connect these many hosts, right? The number of class A networks required is, right? Let's see this one. Class A is asking how many class A network required to connect these many hosts. Let me try this one. One class A network. As of now, one class A network will cover how many? As of now, one class A network will cover how many? 2 power 24 minus 2. These many hosts it can connect. One class A network as of now, 2 power 24 minus 2 hosts it can connect. Right? But, right? So if you want, I can write in the reverse order also. 2024 hosts will be connected with one class A. So let me write in the reverse so that no confusion. Let me write in the reverse. 2 power 24 minus 2 hosts required one class A. Right? Now what about 1.792 billions right? Required how many, right? 1.792 billion hosts required how many class A? So 1 by 2 power 24 minus 2 into 1.792 billion, right? Whatever it is you calculate, you will get the answer. 1 by 2 power 24 minus 2 into 1.792 into billions, right? You know what is the billion value, just substitute, you will get it, right? It's just substitute the billion value. So calculate this value. Tarun, calculate this. So it's going to be 1 by 2 power 24 minus 2 into, right, 1.792 into 10 power 9. 10 power 9. So which will goes to, calculate properly. So which will goes to 1 by 2 power 24 minus 2 into 1792 into 10 power 6. So this one, substitute whatever it is, that is. Now let's go to next problem. Let's go to next problem. So I am arranging this. Fine, that's okay. Calculation only, everyone can do that. Now can you concentrate this problem? What is the answer? Concentrate this problem, what is the answer? Classless inter-domain routing receives a packet with address 131.23.151.76. The router's routing table is as follows, right? Now he is asking the identified output interface on which this packet will be forwarded is. What is the answer for this? So what is the answer for this? So classless inter-domain routing receives a packet with this address. It is the address. It is the address. The router's routing table has the following entries. Right? Simply I think indirectly, directly this problem is do end operation with the mask. Do end operation with the mask, right? Whichever is matching, that will be the answer. So it is a net ID. These are the net IDs. This is the mask. Net ID, mask. Do end operation with that. Net ID and mask. Do end operation. So automatically you will find out the proper interface. So you can go accordingly. Classless inter-domain routing receives a packet with address this. The router's routing table has the following entries. The identified the output interface on which this packet will be forwarded is. Right. So what is the answer? Start. So I think you know very well. You know everyone know this. Everyone know this. If at all multiple answers will match, larger one I have to take. Larger mask I have to take. If at all multiple answers will match, larger one I have to take. First let me try larger one. So 16 ones. 16 ones means 255, right? 16 over, afterward 0, 0. Then it will goes to 131, 23, 0, 0. So can you help, I tried with the option C. Is option C matching? No. So 16 I tried, it is not matching. So let's go for 15. So 131, 23, 151, 76. So I think 16 I tried, it not working. Let's go for 15. This one I will try. 15. 15 means 255, 254, 0.0. It's a 131, it's a 0.0. What about this one? 23 means binary format is, right, 16 plus 23, right, 16 plus 7. 16 plus 7, 16 plus 7 is going to be 23. So let me write now. So binary format is going to be 0, right? So I think you want 23, right? 23, let me cancel it. It is a 16. 16. So next one is going to be, you want the 7, right? This is. Now 254 is going to be all ones. Right? If you do the end operation, fourth bit 1 you will get. Fourth bit 1 you will get. Right? Next one is, I think in the last one, last 2 bits you will get. Right? Before 2 bits, I think so. This is, I think, because of 254 it is 0. I think answer is going to be 0, 1, 1. Last one anyhow will not match. Right? I think 2 people only will match. So this value, if you observe clearly, 16 plus, do properly, 16 plus, I think it is 0. Right? So I will do once again. Yeah, so it is going to be 000, 1110. So I think if you do the end operation, first one you will get 0, second one you will get the 0, third one you will get the 0, fourth one is 1, fifth one is going to be 0, sixth one is 1, seventh one is 1, eighth one 0. So like that you will get, which will goes to 16 plus 6, which is going to be 22. I think same thing. So this one is matching. So interface 1 you have to forward. Answer is A. Interface 1 you have to forward. Answer is A. Hi Ahmad, thank you so much. Thank you Ahmad. So answer for this one is right, option A. Interface 1 you have to forward. Thank you. So let's come to next. Go back and ARQ supports. What is the answer for this? Go back and ARQ supports. What is the answer? Go back and ARQ supports. What will be the answer? In go back and ARQ, right? Go back and ARQ, normally it will goes to cumulative. Cumulative means individual also. Because n of packets are not there, what I will do? 1 is coming, I have to send 1 1 is coming, I have to send 1 1. Cumulative means individual. Individual doesn't mean that cumulative. So answer is going to be C. Answer is going to be C. Actually it is cumulative, means individual also. Actually it is cumulative, so individual also. Because the reason is right. So if m value is 1, it will behave like a stop and wait. M value 1, it will behave like a stop and wait. Stop and wait is going to be individual. So it is actually cumulative. Cumulative means individual also. Now what about this? Which of the following does not require acknowledgement by the receiver? Which of the following does not require acknowledgement by the receiver? Which of the following does not require acknowledgement by the receiver? So if you done the error correction, right, error correction is over means packet is accepted, means you have to send ACK. Which of the following does not require acknowledgement by the receiver? Right? But when you say error detection, after error detection happened, packet will be dropped. After error detection is happened, packet will be dropped. If packet is dropped, no need to send any acknowledgement, because after some time sender timer will be expired, you will resend again. So answer is, which one of the following does not require acknowledgement by the receiver? Answer is detection. B is the answer. Answer is detection. B is the answer, because when you correct it means you will accept the packet. When you accept the packet, you will send the ACK. But when you detect, you will discard the packet, means you don't send the ACK, means sender will resend again. So answer is going to be B. Error detection, there is no requirement of acknowledgement. Detected means what? You don't take the packet. When you don't take the packet, what acknowledgement I will give? Right, that's the answer. Answer is B. It is a really nice problem. This is a really nice problem. Please take care. Anyone having any doubt, let me know. Sir, this is my doubt. You ask me, I will help you. Any doubt? Hare Varun, do you have any doubt? Varun, do you have any doubt? Right, go to the next one. What is the answer for this problem? A 3000 km long trunk is used to transmit frames using a go back N protocol. The propagation speed is 6 microseconds per kilometer and trunk data rate is 1.544 Mbps bandwidth. We ignore the time taken to receive the bits in the acknowledgement. Frame size is 64 bytes. So what is the maximum number of bits of the sequence number? So remember, it's a go back N. So can you try this? A 3000 km long trunk is used to transmit frames using go back N. The propagation speed is 6 microseconds per kilometer. Trunk data rate is, I think, yeah, right, bandwidth is given. Let me write all the parameter so that you will get some idea. Bandwidth is given as, right, bandwidth is given as, bandwidth, let me write now, 1.544 Mbps. That's the bandwidth. 1.544 Mbps bandwidth. And what about the propagation delay or propagation speed? Propagation speed is equal to, what is the answer? Right? 6 microsecond per kilometer. 6 microsecond, let me write now. 6 microsecond. Yeah, micro, right? Micro means 10 power minus 6. 6 microseconds per kilometer. Per kilometer. But how many kilometers total? Right? 3000 kilometers. Multiply by 3000. So 3000 into 6 into 10 power minus 6 seconds. So which will goes to 18,000 microseconds. Fine. 18,000. Right? So 3000 kilometers trunk is used, so propagation delay is going to be 6 microseconds per kilometer. 3000 kilometers are there. 3000 kilometers are there. So 3000 into 6. 18,000 microseconds. Okay, that is the propagation speed, that is fine. I think anything is fine. Yeah, let me go to the one more thing. See this one. RTT is nothing but 2 times of propagation speed. Right, which will goes to 36,000. Right? 10 power minus 6 seconds. If you know the propagation speed, 2 times of propagation speed is RTT. Right? That is also fine. So anything else there, let's check. And one more, remember, it's a go back N protocol. The propagation speed is 6 microseconds, so I think all the data, whatever is given, we utilized. Frame size is 64 bytes. Frame size is 64 bytes. What is the maximum number of bits of the sequence number? Yeah. So I think because of everything is okay, so I am writing now. Now listen everyone now. Listen everyone. Bandwidth is 1.544 Mbps. See this one. 1.544 Mbps bandwidth. So what is the meaning? Right? The meaning of this one is 1.544, right, megabits per second. Megabits per second. So per 1 second you can transfer 1.544 megabits, so 10 power bits per second. These many bits you can transfer. That is the 1 second. But what is the RTT time? What is the RTT time? One RTT is equal to, right, 36,000 into 10 power minus 6 seconds. In the second you can transfer 1.5444 into 10 power 6 bits. These many bits you can transfer. So I think both will be cancelled. So it will goes to 36,000 into 1.544. These many bits you can transfer, right, in 1 RTT. In 1 RTT, these many you can transfer. How many frames? One frame size given 64 bytes by 64 bytes. You will get the frames. 1 RTT, these many frames you can transfer. These many frames. If you divide, you will get this one. So I think these 3 zeros. So bytes it is, right? Into 8. Let me calculate properly. 36,000 1.544 by 64 into, right, 8. So calculate properly. 8 ones, right, 8 ones. So anything, so calculate properly. 36,000 into 1.544 by 64 into 8. These many frames will come. These many frames. Whenever these many frames came, if you want to know sequence number of bits in the sequence number, just apply log of this. Just apply log of this. Calculate properly. Calculate. What is the value? 36,000 into 1.544 by 64 by 8. Those many frames, apply log, you will get the number of bits in the sequence number. Check one time. So I have not done anything. So bandwidth is given. Let me revise once. This one, bandwidth is given. Right, next one. The twist here is propagation speed given per kilometer, but total propagation speed is going to be 3,000 into, right, per 1 kilometer. How much? Because 3,000 kilometer. So 18,000 into 63 is 18,000 into 10 power minus 6 seconds, which can also be written 18 into 10 power minus 3 seconds. 10 power minus 3 seconds. So, right, 18 into, so when you say RTT, double, 36 into 10 power minus 3 seconds, right? Fine. Next one, in 1 second I can transfer this much. In 1 RTT, how much I can transfer? This much. This much means in terms of frames, how much? By 64, because one frame size 64, right? One frame size 64. Now, if you observe clearly, these 3 zeros you can remove. It became 1544. Just do calculation, you will get it. 36 into 1544 by 64 into 8. Right? So you just calculate, apply log, you will get the answer. So So someone is saying that increase mic volume. Let me try this. Right, so that will be the answer. So right, just calculate, right, log of that value you calculate, you will get the answer. Fine, so that is the answer for this. I am not done anything, right? Whatever he mentioned, first I collected his data, what actually is asking, just I mapped it. So what about this? Can you try this one? Two peer processes A and B use stop and wait ARQ to send packets over a single link with capacity C. All packets have the same length of 100 bits. The round trip time is equal to 2 seconds. Assume that no packets or ACKs are dropped and that all packets and ACK are error free. Furthermore, assumes that the capacity C is equal to, right, 1 lakh bits per second. Find the average rate with which process A sends data to process B. Find link utilization. So two things they are asking. It is the question number 1, it is the question number 2. Right? Please collect the data. Lastly, we can see what actually is asking. If you directly try what he is asking and all, you may not get. First, collect data. Two peer processes A, B use stop and wait ARQ to send packets over a single link with capacity C. So capacity, right? Capacity means, with capacity C means, I think, bandwidth. Right? Furthermore, assume that the capacity C is equal to 1 lakh bits per second. Right? This is the capacity, which is the bandwidth. So bandwidth is given. Please careful. So let me write all of them. Bandwidth is given as 1 lakh bits per second. That is the capacity. Fine. So I have a bandwidth. Anything else? Check. All packets have the same length of 100 bits. So packet have the length of 100 bits, means he is given the packet length 100 bits. If required, we will use it. The round trip time is equal to 2 seconds. RTT is given as 2 seconds. Okay. ACKs are dropped and that, right, all are error free. RTT is given this. All packets have the same length of 100 bits. Okay. Find the average rate with which process A sends to process B. Find the average rate means which is nothing but throughput only. Find the average rate with which process A sends to process B. Average rate means, right, average data rate. He is not asking efficiency, he is asking the data rate. Means throughput is asking. Right? Next one is utilization, first one is throughput. And it is a stop and wait protocol. Means one packet only you can send at a time. Can you help me? Is it possible to find out propagation delay? Sorry, is it possible to find out transmission delay? Is it possible to find transmission delay? Yes, 100 bits by bandwidth. Right? You can transfer. Right? You can find out the propagation delay. That is also okay. Right? Please help me. How much data? Right? So let me try this. See this one. See everyone. Propagation delay or propagation time is equal. Sorry. Transmission delay TD is equal to, right? Next, what is the answer? Frame size by bandwidth. transmission delay is equal to frame size by bandwidth. Because of it is a stop and wait protocol, it is a stop and wait protocol, one frame only you can send. So what is the answer? 100 bits by 100 bits by, right? What is the bandwidth? Bandwidth is going to be already is given, right? 1 lakh bits per second. Bits cancel. So which will goes to, I think 2 bits are cancelled. 1 by 1000 bits. Right? Because of the right bits cancel, so seconds will come. Which is going to be 1 millisecond. Which is going to be 1 millisecond. Check properly. I have not done anything. Transmission delay is equal to, right, frame size by bandwidth, which is going to be 100 bits by 1 lakh bits per second, which is going to be 1 milliseconds. 1 millisecond. So RTT given 2 seconds. RTT given 2 seconds. Right? Next one. Transmission delay is given 1 millisecond. Right? Now be careful. See this one. What about finding throughput? Finding throughput what? Right? Let me try this one. Throughput is equal to, right? How much data you are transferring to be 100 bits. 100 bits by what is the transmission delay? 1 milliseconds plus what about RTT? 2 seconds, which is going to be 100 bits by 2.001 seconds. Right? This is the answer for this. This is the throughput. Check. 100 bits by 2.001 seconds. I convert it to the milliseconds. It is the seconds. Right? So if throughput formula is going to be how much you are transferring data, 100 bits by, right, transmission delay plus 2 pt, which is going to be RTT. RTT means 2 pt. So 1 milliseconds plus 2 pt, right? 1 milliseconds plus 2 seconds. 100 bits by 2.001 seconds. That is the throughput. Now, can you help me? What about link utilization? Link utilization is nothing but, right? When you know, everyone know link utilization is nothing but both are times only. So can you help me? What is the transmission delay? Transmission delay 1 millisecond by, right? So 2.001 milliseconds. Sorry, seconds. Link utilization. Link utilization means a transmission delay by, right? Transmission delay plus RTT, right? 1 millisecond by 2.001 seconds, right? This is nothing but 10 power minus 3 seconds by this. You calculate whatever you will get. That is the answer is going to be link utilization. This is a link utilization. Just apply link utilization formula. Just apply link utilization formula. Just apply link utilization formula. Link utilization formula is going to be, right, transmission delay by transmission delay plus RTT. Efficiency into bandwidth. Someone is mentioned efficiency into bandwidth. So both are same meaning is same. Calculate properly. Link utilization is equal to transmission delay by transmission delay plus RTT or 2 pt. So that will be the answer. Calculate, you will get it. So you, like someone is saying some other formula, both are same meaning. Now go to the next problem. So calculations I am leaving because you can do calculations. Calculations I am leaving because you can do calculations. Right? Yes, that is correct. Go to the question number 120. Sorry, question number. If the bandwidth of the line is 1.5 Mbps RTT is 45 milliseconds and packet size is 1 KB. Then find link utilization in stop and wait protocol. So given parameters you write first. I think bandwidth is given as 1.5 Mbps. 1.5 Mbps. That means let me write now. So 1 second you can transfer 1.5 Mbps. 1.5 10 power 6 bits. So 1 RTT. 1 RTT how much you can transfer? 1.5 into 10 power 6 bits per second, right? Bits per second, right? Into 1 RTT. What is 1 RTT? 45. Milli means -3. Seconds means I already written. Seconds means this. So finally bits. This one came. So bandwidth is going to be 1.5 Mbps. That means 1 second these many bits I can transfer. Means in 1 RTT these many bits I can transfer. Okay, these are the bits. And he is saying that packet size is 1 KB. Divided by 1 KB. You will get the packets. You will get the packets. Okay, that is fine. And one more. What he is saying? Stop and wait protocol. I think it is actually maybe not required, right? 1 RTT, this much data I can transfer. Okay, data, right? Given data, you can use whatever way you want. Bandwidth given, 1 second, how much you can transfer, 1 RTT, how much transfer, I calculated, right? If required, I will use it. If not required, I don't use. Let's see. Link utilization. What is the link utilization formula? Link utilization formula is going to be transmission delay by transmission delay plus RTT. Transmission delay, let me calculate transmission delay. Because of stop and wait protocol, 1 frame only you can send, 1 packet only. Let me write. Transmission delay is equal to, transmission delay is equal to, it is required, right? 1 packet. What is the 1 packet? 1 KB. 1 KB means 10 power 3 into 8 bits. By bandwidth. What is the bandwidth? 1.5 Mbps. 10 power 6 bits per second. Bits cancel. Right? Seconds are there. So if you do calculation properly, 8 into 10 power 3 by 1.5 into 10 power 6. So both are cancelled. It became 10 power minus 3. So it became 8 by 1.5 into 10 power 3. Right? These many seconds. So just to find out TD. Okay, I calculated. Transmission delay I calculated. RTT already is given. Right? What is the link utilization formula? This is the link utilization formula. Transmission delay by transmission delay plus RTT, which will goes to transmission delay already we calculated 8 by 1.5 into 10 power 3 seconds by same 8.8 by 1.5 plus 10 power 3 plus what is the answer? What the RTT is given? 45 milliseconds. 45 milliseconds, 10 power minus 3 seconds. So this is going to be link utilization. Using calculator you have to calculate properly, right? This is first step. Maybe not required also. This part is not required. So let me remove this. I thought it is required, I done. Let me remove it. Not required, to be frank. Those people who are not getting, can you see this? Those people who are not getting this one, can you see this one time? It is the first step. It is the first step. It is the second step. Link utilization. Link utilization is equal to this. Transmission delay is this. Only 2 steps are there. Calculate properly, you will get the answer. Sir, why are you using data as multiples of 10 why not multiples? Both differ by small constant only. It's calculation easy, right? Right? When you say KB, kilo, right? Kilobyte. Kilobyte, right? No, whatever, it's very difficult to say. It's very difficult to say that. But difference by very small. Whether you take 2 power 10, right? 2 power 10 also okay. 10 power 3 also okay. Difference by very small number. So it may not affect that much. Whichever is convenient you can take. Difference by very small will be there. No need to think that much. Calculations point of view, which is easy, you take it. Thank you so much for asking nice question. Kashi, thank you. Because microseconds, see, microseconds we will take 10 power minus 6. Milliseconds we will take 10 power minus 3. Right? Mega will take 10 power. All are 10 powers coming. This also you can take kilobyte. You can take 10 cube also. Or if you want to take 2 power 10, that is also okay. Right? So I think you can take whichever is convenient to you, you can take. Accordingly, you will adjust the options. Accordingly, you will adjust the options. If you want, you can take 2 cube also. See this one. This is, right, kilobyte, right? Kilobyte. Kilo, you can write 2 power 10. See this one. If you write 2 power 10 here, if you write 2 power 10 with the 10 power 6, cancellations becomes difficult. Because differ by small thing. Differ by small thing, it will create some trouble to you. Right? It will take, see this one. Here kilo there, I written 10 power 3. If I write 2 power 10, it is a 2 power 10. It is going to be 10 power 6. So cancellations are very difficult. So that is the reason they used to take according to their requirement. Both are correct, differ by very minute value. So I think this problem, very small, it is given in the previous paper. 1 and 2, only 2 steps are there. Only 2 steps. Now what about this? G of x is equal to, means generator polynomial is given, message polynomial is given, find polynomial of code word. In sender code word you have to find out. If receiver code word is this one, then find how many bits are differ. Means simply find out the code word. Sender code word find out using given information. Means it is something like CRC. Error detection technique, CRC. It is the error detection technique, CRC. Right? Just to do CRC, you will get the answer. What is the meaning of x power 4, x power 1? X power 4 means 4th bit is 1, 3rd bit is 0, 2nd bit also 0, 1st bit is 1, 0th bit also 1. So I think 5 values, 5 bits, 1 0 0 1 1. What about message polynomial? 7th bit is 1, 6th bit is 1, 5th bit not there, 4th bit is 1, 3rd bit not there, 2nd bit is 1, 1st bit is 1, 0th bit is 0. So you have both the things, right? So you have to do CRC. What is the CRC? 1 0 0 1 1. Right? So message polynomial, if you observe, 1 1 0 1 0 1 1 0. Right? So here 5 people are there, 4 bits attached. Then start dividing. You will get the answer. Lack of space, maybe I will adjust somehow. Let's check. So I think space not possible also. So I will try. So if you do one time, it will become 1 0 0 1 1. Do exclusive OR operation. 1 1 0 1. This is 0. Every time, right? MSB bit will go. Now actually you have 5. It is 4. 1 bit bring from here. So it's 1. So 1 times you do 1 0 0 1 1. It's going to be 0 0 1 0 0. Right? Again borrow 1 bit from here. Right? Now it's going to be 0 times 2. 0 will come. Right? Lack of space. I will adjust somehow here. So it became, if you do the end of exclusive OR operation, it will become 0 1 0 0 1. So this is gone. Borrow from here 1 0 k. So it became 1 0 0 1 1. So it became 0 0 0 0 1. So this is gone. Borrow one more bit from here 0. Again, so 0 times. So it will become 0 0 0 1 0. So this is gone. Again one bit borrow from here 0. So again if you do with 0, the answer what you are going to get is 0 0 1 0 0. This is cancelled. So from here again one more 0 will come. So it will goes to 0 0 0 0 0 0 1 0 0 0. This is cancelled. So one more bit will come. It's a 0. Now if you do with one time if you do, it will become 1 0 0 1 1. It will become 0 0 0 1 1. So this is cancelled. So finally this is the bit which you are going to add. So answer is 0 0 1 1. So sender code word is asking, then find, right? Then is asking find sender code word. Sender code word is going to be 110 10 110. Lastly you got 0 0 1 1. Verify. Sender code word is this. Now receiver code word, what is given? See the receiver code word. Receiver code word is given. You know very well, right? You know very well. How many bits are there in the data? Data bits are going to be 8. Data bits are going to be 8. Next one, CRC is going, right? CRC is going to be 4. 8 plus 4, totally 12 people. Totally 12. Let's check here. 11th bit is 1. Receiver got 11th bit is 1. 10th bit 0. 9th bit is 1. 8th bit is 1. 7th bit is 1. 6th bit not there. 5th bit not there. 4th bit not there. 3rd bit is 1. 2nd bit is 1. 1st bit is 1. 0th bit is 1. Like this. So this is the thing what you sent. This is the thing what the receiver got. Please check where is the wrong. Please check where is the mistake. Let me verify the mistake. This is no problem. This is problem. This is problem. So it is a problem. It is a problem. Next. 4th one. No problem. 5th one. Problem is there. 6th one. Problem. 7th one. Problem. 8th one. No problem. 9th one. Problem there. 10th one. Problem there. 11th one. No problem. 12th one. No problem. So I marked also. Right? This is having problem. This is having problem. Next one. This is having problem. This is having problem. Right? Next one. This is having problem. This is having problem. Just like that. Please verify properly. You will get the answer. Like that you can check. So sender code word you find out, with the receiver compare, you will get the answer. You did wrong mistakenly. Where I done wrong? Please verify where I done wrong. Yeah, maybe I think everyone in the, because of big procedure I done, I may be done somewhere wrong. Please verify properly. One zero zero 1 1. 1 0 0 1 1. Yeah, maybe in the big flow, maybe I done the wrong, but this is the procedure everyone know. This is the procedure everyone know. Please cross check one time. But you know the procedure, right? You know the procedure. I done little bit faster. I hope everything okay. If small doubt is there, you can rectify by yourself. Right? Fine. Can I go to next? Can I go to next? Please verify properly. So message data is given. Message data is given 11010 11010 110. Yes. Afterwards 4 people. Oh. So I think correct only, right? One time 10011 1. Oh, here 0. Here mistake happened. Right? This is 1 only. Here mistake happened. But anyhow, yeah, you know this entire procedure, because starting only mistake happened. I have to rectify all. It's okay. It's okay. No problem. Right? No problem. You can handle it. Yeah, I got. This is the mistake. Right? Please take care. So this is 0. Right? So it is going to be 1. It is a 0. It is 0. It is 1. Right? When you cancel, right? It is going to be 10011. It will become 0 0. It will become 0. It will become 0. Right? So when you substitute, right, then it will become 0. So you copied 1, it will become 0 0 0 0 1 0 0 5 zeros. It will become, let me try this one. 1, it became 1. It became 1. It is a 0 0 0 0. Previously 1 came, now it will become 0 comes. It is a 0. It is a 0. So I think there is a big change is there. There is a big change is there. I hope you know the procedure you will do. Here small mistake happened starting only, then all will be automatically, some changes are there. Fine. Accordingly you can plan it. Right? Let's go to next problem. So yeah, so in the next class, I think this problem is similar like previous problem. This problem is similar like previous problem. The only thing is numbers not given. Numbers not given, variables are given. So you have to properly do the calculations. Previously at least calculations are required. Now calculations also not required. Numbers not given. Same thing like previous problems. The only thing is variables are given. Please take care. Answer is option C. Answer is option C. Yeah. So with some more problems we'll see in the next class. Thank you so much for attending. See you in the next class. Thank you.